when we talk about the set of whole numbers, we talk about the set of natural numbers. Can anybody tell me what distinguishes the set of whole numbers from the set of natural numbers? Right, natural numbers are used for counting, and whole numbers. What? That's it. That is the distinguishing feature, right? Whole numbers, the set of whole numbers includes the number 0. Alright, so that is how we could distinguish between the naturals and the whole numbers. Because if we really and truly look at the set of whole numbers, you'll find all the natural numbers in there, but the only thing that makes it different is the fact that you have 0. Then integers deals with our positive numbers, our negative numbers, and inside there we will also find 0. So anybody wants to tell me what they remember about the set of integers? Just a second, somebody was overlapping there. So can you repeat that for me, please? Oh, so you remember arithmetic. Okay, nice. I'm liking that you bring up the arithmetic, because with all the types of numbers that we deal with, we are always going to be learning how to do arithmetic on those sets. So back in primary school, you would have learned how to do arithmetic with whole numbers. Last term, we actually had a bit of a headache, maybe, dealing with the arithmetic on integers, because integers might be one of those things that happens to give people a lot of problems. And then, like I said, this time we're going to talk about rationals, and rationals, like I said, fractions. I am sure if I ask everybody, they're going to say, oh my god, I never really liked fractions back in primary school. So we know we're going to have a few little hiccups there, alright? But in the set of integers, a couple of things that I want to highlight, and especially for the benefit of, our new people to kind of catch up to where we're at. This set of integers, it contains positive numbers, like we said, negative numbers, and it also contains 0. Does anybody remember what the number line looks like for this set of integers? So let's see. So I heard 0 in the middle. Lovely. Very good. So to the right, let's do the right. We're accustomed to this side of the number line from since primary school. We go 0, 1, 2, 3, 4, and we keep counting upward, going to the right. But on the left side, what's the first negative number we ever find? -1. Nice. -1, and then we keep going backwards that way. So like someone said earlier, 0 sort of separates the number line into the negatives on the left, positives on the right. And something that I was highlighting last time, it's like a mirror image. It's almost like when you look in the mirror, you are facing the mirror, so when you look into the mirror, you're seeing your face, right? That's your reflection. So the number line is like a mirror image of your positive side. The negative side is like a mirror image of your positive side, but it's just that it's going to have negatives over on the left side, alright? So we need to always remember what our number line looks like, because this number line can be applied to things like later on you learn about coordinate geometry, and you're going to learn that we have the negative and the positives for how we will be doing our coordinates with plotting points and stuff, right? So this is going to be really important, knowing how this number line works. So let's talk about the irrational numbers, alright? Anybody could recall an irrational number for me? What is an irrational number? Okay, Okay, somebody remembers pi, the constant pi. So for those of us who don't know what pi is a circular constant, and you'll meet it when we start dealing with the circle in Form 2. You're going to meet pi, and that constant is an irrational number, because if you all Google it, and later on, well, actually not later on, next day, when you all are in Form 2, for those of us who oh gosh, I'm confusing myself. Later on this year, we in a whole new year. Later on this year, in March. Wow. I am really out of it. Anyways, in March, we're going to be having a celebration called Pi Day, and you will learn about pi. You can actually Google it. You'll learn about Pi Day. You'll learn about what pi is, and why we celebrate Pi Day on March 14th, right? But the constant pi is 3.14159 something 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 going on forever and ever, amen. And you could look it up and you will see that there's so many digits in that decimal. So that's one of the reasons why it's an irrational number, alright? And there are other irrationals as well. So back when we were talking about different types of numbers, we talked about rationals, and like I said, rationals, we know examples of rationals would be fractions, which we all loved so much back in primary school, right? So these were all examples of rational numbers. Now when we talk about irrational numbers, we're talking about numbers which cannot explicitly be expressed in this rational form, where in the case of non-terminating decimals like pi, like I just said, 3.14159, and you research it and you'll see it goes on forever and ever. There's also the square root of certain numbers as well, where you have non-terminating decimals. So there are some numbers we know the exact square root of it, but then there are some numbers we don't know the exact square root of, simply because when you find the square root of the number, it is a decimal that keeps repeating itself. Alright? So these are some examples of irrational numbers. Now, real numbers. Anybody want to tell me what they remember about the set of real numbers? Nice. It is any type of number, because the set of real numbers encompasses all the number sets that we talked about. We talked about the integers, we talked about the whole numbers, we talked about naturals and rationals and irrationals when we talk about real numbers. Alright? So now that we know naturals, whole numbers, integers, rationals, irrationals, and also real numbers, let's talk a little bit about some arithmetic. Alright? So let me erase this. So how many of us here remembers what we do when we have a statement like yeah, like this. What do we do? What do we do? So as she said, BODMAS. Anybody remembers what this acronym stands for? Brackets. Whoa, okay, so I heard lots of overlapping, but I got this. Brackets. Brackets. Alright. Brackets. So back in primary school, some people would have learned different versions of this. Last time I told you all we use orders, simply because there are times when you are going to meet powers. So we need to know when do we handle powers, and we handle the powers right after the brackets before we do division, multiplication, don't run off the board. Alright, squished. Addition and subtraction. Alright, so this is BODMAS, alright? Anybody wants to, well, I shouldn't say anybody. Everybody could work this out for me, and then you all can use the chat and tell me what you got for your answer. So, I'll give you all 2 minutes to work on that. What do you get for your answer? You all will tell me via the chat. So you'll type your answer in the chat. And for the people who can't use the chat, that's okay. Remember, you all have the option when I ask a question, you all can tell me what your answer is. So 2 minutes, work it out. I'm sure some people might finish this in no time as well. Let's see how many people can get the answer. So let me see if I could put some answers on the board, and people can probably respond with, you know, what they think their answer. Well, you got your answer already? Alright, so just now. Okay, so I heard somebody say 10. Alright. So I'm just putting random answers at this point, right? So somebody said they got 10. Let's see how many people got an answer. Alright, so I have another 10. Alright, so y'all, get ready. Raise your hand if you got 10. So I saw Letitia's hand was up. Oh, look at that. We have a few hands up. Alright, raise your hand if you got 10 as your answer. And I'm seeing the numbers going up. So we have about 27, 29, 31. Look at all these brilliant students. 35. Keep it coming, keep it coming. 39. 40. And still counting. That is nice. 42, 44. 45. Alright, so 46, 47. I'm liking this. And we have like 66 persons in this meeting, which is lovely. So, hands down, right? Hands down. So for everybody who got the answer to be 10, yes, your answer is 10, and we're going to work it out, and we'll see why the answer is 10 for those of us who probably are like, what? How? When? Where? Alright? So we're going to start off by looking at our numerical statement. Now, our numerical statement is 24 divided by 8 minus 5 plus 2. Now, once we start seeing things like mixed operations and brackets, we immediately will call to memory BODMAS. And BODMAS tells us we do brackets first. So, this is the reason why we started off. And I hope you'll remember to do this. Write your statements properly. Alright? So, once you remember how to do that, when you all have to submit working for me, you all will not be losing marks, because last term it was sad that I had to deduct marks because people had answers without working. Alright? And I don't want to have to repeat that this time. So make sure you remember to do your statements properly. Alright? So when we do 8 minus 5, we get 3. And then from here now, the next thing we need to do is this division. Alright? So we're going to do 24 divided by 3, which will give us 8. And then we'll do addition. And 8 plus 2 will give us 10. And that's how we get our answer. Right? So our answer, final answer, is 10. So everybody, give yourselves a nice little clap. That was a really good job. You'll remember how to do your stuff. Alright. So, let's move into another question. Alright? Now, like I said, last term was heavily into the number theory aspect. And we didn't just deal with, BODMAS. There were some rules that we also looked at. Anybody could remember some laws of arithmetic from last time? Alright, so I heard 2 so far. I'll write it down just now. Laws of arithmetic. Alright. My handwriting, terrible. Okay, so I heard commutative, so I'll start with that one. Commutative, distributive. Lovely. So they recalled all three. So commutative. Is there not a faster way to write? Commutative. I'll put associative next, because we usually learn it like that. Associative. And then distributive. So anybody wants to tell me what they remember about commutative, the commutative law? Anybody? What does it mean? Say it back again. Oh, okay. So I think you know what you want to do, but at the same time you're not too clear. Alright. So let's say we have two terms. Alright? Let's just think about the operation of addition. So let's say we have A plus B. A plus B, now, although these aren't numbers and we can't work out a number, if we were to write it as B plus A is basically the same thing. Alright, so this is what the commutative law is telling us. So let's think of a simple example. Let's say we had 2 plus 3. If I write 3 plus 2, isn't that the same thing? Isn't it going to give me the same answer? That's it. Exactly. So that is what it means when we say commutative law. We're talking about when we can perform an operation in any order on two terms or two numbers. And something I want to make sure and emphasize, you see things like directed numbers, you see these laws of arithmetic, please do not forget them, because when you're going to form 2, you're going to build on this, and it's going to be very important for you to remember these things, because not everybody is going to be willing to recap things, alright? They expect these things of you, and you need to make sure that you have that foundation. So do not forget these things, alright? So this is your commutative law. So anybody can remember which operations are commutative? So I heard a lot of things, but I think I got addition and multiplication, right? So addition and multiplication. Okay, hopefully you can hear me over X. But addition and multiplication are both commutative, because those are the two operations that I can perform in any order on two numbers, and I'm going to get the same response. I'm going to get, so like we just said, 2 plus 3 is 5, 3 plus 2 is 5. And if I do 2 by 3, I'll get 6. And if I do 3 by 2, I will still get 6. So this is the reason why we need to know what the commutative law is, so we can identify what it means to be commutative, and we can identify operations which are commutative. Now, subtraction and division do not have that commutative property. So this is the reason why, like I was telling you last term, back in primary school, some people would have learned that you can't take away a bigger number from a smaller number. But when you learn about directed numbers, you learn that when you subtract a bigger number from a smaller one, you get a negative response. So we will deal with the directed numbers later on, but this is what we wanted to recap with the commutative law. Alright, associative. Anybody wants to tell me what they remember about associative? Lovely. I was now going to write down, well, as you see, I write in down order because I wanted the keywords to be something that you'll connect with the laws, right? So commutative law relates to order. Associative law relates to grouping. So as she just said, grouping. Alright? Now when we talk about grouping, we're talking about when we regroup terms in order to perform an operation. So let's just say I had something like 3 plus 2 plus 5. Alright? There are two ways in which I could group these numbers to add them together. Because addition, subtraction, multiplication, division, they essentially are what we call binary operations, meaning that we can only perform the operation on two terms at a time. So this is the reason why we need to know about things like associative law. So one way in which I could group the numbers is that I could add 3 and 2 together first and then add 5 to it. Or I could add 3 after I add 2 and 5. And I'm going to get the same answer. So when we talk about the associative law, we're talking about how we group the terms together before we perform the operations. Alright? So this is associative law, and the two operations which are associative are, again, addition and multiplication. Simply because they are commutative and the order in which we perform the operation on numbers will not affect the final result, this also can be extended into the associative law, and hence addition and multiplication are both also associative. Then finally we have distributive laws. Anybody can recall what distributive law does? Anybody? Close enough, because you could use it. I showed you all how to use it to do long multiplication, and some of you would recall doing those things back in primary school as well. But distributive law, what anybody wants to explain what the distributive law does? What's a key word connected to it? There you go, distribute. Alright, so distributive law tells us that an operation can distribute itself over another. So can anybody tell me which operation can distribute itself over another? Lovely. Multiplication. Alright, we'll talk about division after. Multiplication is what the distributive law applies to. Alright? The division, I could show you all something concerning the division. Alright? But it entails using the reciprocal of the number versus using division itself. But anyway, let's deal with this first. Not confuse too much things at once. Alright, so just remember, whenever you're doing distributive law, think of multiplication being able to distribute itself over addition and subtraction. Alright, so for example, if I were to tell you all that I wanted to work out this. I can use my distributive law to work this out. Alright? And how my distributive law will work is like this. I will say 5 multiplied by 10 plus 5 multiplied by 7. Alright? And this is what I was talking about. I think Chaya brought it up just now. That when you want to work out a number, you could break it up into like the tens and the ones and multiply the tens and the ones by the multiplier, and you'll get the answer. So 5 by 10 is 50, and 5 by 7 is 35, and this will give me 85. Alright, so like I was saying, let's just say you looked at this statement at first, right? And your brain automatically said, well, 10 plus 7 is 17, and then you come 5 by 17, and you sat down there for a second, and you're like, let's just say you're in the position of, I never learned beyond 5 times 12. Then you can use your distributive law here, like this, to be able to work out what 5 times 17 is without having to, do like long multiplication, because you could break it up into the sum of 10 and 7, and that's how you could use your distributive law to work out the product. Alright, so whenever you think about distributive law, I want to remind you, hopefully you're not hearing Rex as much as me, but when you do the application of distributive law here, it is 5 times 10, right? So it's always going to be whatever is outside your bracket multiplied by the first number, and whatever is the operation. So in this case is addition, then you add that to this outer term by this term. Okay, so always remember it's multiplication distributing itself over operations such as addition and subtraction. Now somebody mentioned division earlier, and there's a reason why I hesitated to say the division, but let me show you all something. Alright, so division. Okay, so let's say I gave you a statement like this. Can division distribute itself over the subtraction? Think about this a little bit. So think about the numerical statement that you're looking at here. If you had to work this out, what would you do? Anybody, tell me, what would you do? Ignoring distributive law, you're looking at a numerical statement alone, so you're only looking at this. That's it. That's it. Alright, so I heard it twice. You're actually going to work out what is in the brackets first, because that's BODMAS. And 13 minus 7 give me 6, and then you could work this out. 12 divided by 6 is 2. That's it. Now, the thing is, right, the thing is over here. This is the reason why I said division isn't the same as multiplication, right? Aside from that, I don't know if anybody remembers from last term, identities and inverses, alright? But we'll talk about that in a little bit. Here we have division, alright? And this is the reason why we can't distribute division over other operations, because 12 divided by 13 minus 7 is actually saying that you're dividing 12 by this statement here, this 13 minus 7. Alright, so that's the reason why you can't say division is going to distribute itself over another operation, right? If it were written differently, alright, and this is why I mentioned identity and inverses, because let's say I had this instead. 1 over 12 multiplied by 13 minus 7. This in itself is like kind of saying division, because 1 over 12 is the reciprocal of 12, and just to avoid confusing things, but when you will deal with rational numbers, anybody remembers how you divide fractions? Yes. Okay, so you'll remember the process for division of fractions. Somebody just tell me, what do you do when you have to divide fractions? So let's, you'd invade the second fraction, right? Right, so this is what I was trying to get at. Yes, what you all said there is correct. You'll change, so first you will invert or flip or find the reciprocal of the second fraction, the one that follows the sign. So you keep the first fraction as it is, you flip the second fraction, so this would become 4 over 3, and you change the division to a multiplication. Alright, so that's what I was trying to get at. If you could recall this 12 by thing would kind of make some sense, all right? But you have to utilize the reciprocal if you want to do division. But like I would say, try to avoid confusing things and ignore this piece here. We're trying to distribute division over other operations and stick to what we were talking about, where multiplication can distribute itself over operations of addition and subtraction, right? So when you talk about distributive law, I want you all to always remember multiplication distributes itself over addition and subtraction, all right? So your laws of arithmetic, your commutative law, associative law, distributive law, all right? And before we get into recapping some directed numbers stuff, let's talk about identities and inverses. So anybody here could remember anything at all when I talk about identity and I talk about inverse? So you don't need to remember the full formal definitions or anything. I just want you all to explain to me what you understand by identity and inverse. Anybody? Waiting. Anybody? Sure. All that will work. Alright. So I'm pretty happy to hear this statement because this actually ties the two things together. Alright? This particular statement is connected to inverse, but also at the same time connected to identity. Alright? And here's how we'll make the connection. So first of all, let's start by looking at 0. Alright? Let's think of a simpler statement. So let's just say I had asked you all to add a number to 4 so that 4 remains the same. What would you add to 4 so that you'll get back 4? 0. Alright? Now let's look at it again now for multiplication. Alright? If I ask you all to multiply 4 by a number so that I get back 4 as the answer, what would you all multiply 4 by? 1. There you go. 1. Alright? So these two numbers, 0 and 1. 0 is what we call the identity under the operation of addition. Alright? So whenever you talk about identity, there are two identities that we need to know about in arithmetic. The identity under addition, which is 0, and this guy over here, who is the identity but under the operation of multiplication. Alright? So if I ask you all, what is the identity under addition? You'll tell me 0. And if I ask you all the identity under multiplication, you'll tell me 1. Now, back to the statement she gave us, which, like I said, is a very good statement to really tie together the two things. Because if you all look at it, can you all identify an identity in the statement that she gave us? 0. Beautiful. 0. Alright? 0 is an identity. It is the identity under addition. Now, what do you notice here? She's added negative 4 to positive 4 and she's gotten 0. So what negative 4 actually is the inverse under addition. Alright? And again, just like there are two identities, there are two inverses. So let's look at it now. Alright? The inverse under addition. Can you all tell me what is the inverse under addition? If you had to explain to me how we got this inverse here, what would you tell me? It's the negative of that number. That's it. Nicely summarized, alright? So the inverse under addition is the negative of the number. So if I have positive 4 and I want the inverse, of positive 4, I will take negative 4. If I gave you all 17 and I told you I want to get 0 as the answer, what would you add to positive 17? Negative 17. There you go. Alright? So the inverse under addition is the negative of the number. Now, what about multiplication? Anybody here could tell me what they remember about the inverse under multiplication? So somebody said 0. Think about it. So let's say I have 4. Remember, we're doing multiplication. What will be 1? The result? Okay, I'm hearing lots of things. So first, 4 by alright, so this is what I want to stop at. Anybody have their mic unmuted? Just mute in case, right? Don't want any echo. Alright, so let's talk. First things first is this. What is 0 again here? The identity. Identity, is it specific to a particular operation, or is it generally the identity under everything? Okay, alright. So I'm hearing some overlaps, right? So just remember, because I can't really, when I'm sharing my screen, I can't really see who has a hand raised or whatever. If you hear somebody talking, just give them a chance, right? And I know sometimes with lag, nobody is really know what's going on. But yeah, identity under addition, it is specific, like somebody said, it is specific to addition. This identity is specific to addition. So this is the reason why I am stopping at this statement for a while, to just kind of clear up something. So if this is the identity under addition, what did I just say about negative 4? I said it is the inverse under what operation? Addition. There you go. So do you all understand that this statement is very, very, very specific, right? It is not just that you could take any random operation and drop that in there and you're going to get the same result. 0 is the identity under addition. Hence, if I add the inverse under addition to a number, I should get the identity under addition. What is the identity under multiplication? Anybody? 1. There we go, 1. So let's talk about this numerical statement. So if I want to demonstrate, like how we did with the 4 plus minus 4 is equal to 0, what would be the statement here for the inverse under multiplication, right? Ignore this piece yet. This is going to remain blank because I want to know what number I'm going to multiply 4 by, so that I should get back the identity under multiplication. Okay, so this is why I had to pause, because this numerical statement is specific to addition, and what is specific to multiplication now, we need to make sure that we have the identity under multiplication as the result, right? So my question to you all now, I want to multiply 4 by some number so that I can get 1 as the result. Anybody wants to tell me, what will I multiply 4 by to get back 1? Okay, so I heard a couple things, so just give me a second. So I'll write down the minus 3 and I'll write down the 1/4, and let's take it to the eyes. So can you all raise your hand if you think the answer is negative 3? Do you think the inverse under multiplication is negative 3. Raise your hand if you think it's negative 3. So I see 2 hands, 3 hands, 4 hands. 5, 6, 7, 8, 9. Alright, going once, going twice. Make that 12. Alright, so we have 12 persons. Make that 13. Alright, 13 persons who say the answer is negative 3. Put your hands down, ladies. Alright, so when all the hands go down, I'm going to ask my next question. Alright, so Shadi, Priya, hands down. Alright, so I got your message, Annalie. Let's see the hands. How many eyes say it's 1/4? Raise your hand, loud and proud. Be about, let's see, whoa. So I have like 12 hands up already. Oh, whoa, we went 20. So we have 22, 23. Raise your hand and be counted, people. Raise your hand. Do you think it's 1/4? We have 26, 25 now, 26. Raise your hand if you think the answer is 1/4. So I'm giving you all 10 seconds to raise your hand again. Alright, for all the people who think the answer is 1/4, raise your hand. Alright, so we have about 28 now, 29, 30, going once, going twice, and there we go. So we have 31 persons in total who have said the answer is 1/4, and in fact, the persons who said 1/4 are correct. And here's why. Let's talk about this now. So hands down, ladies. Thank you very much for participating in today's very first poll for the day. Let's talk about why the answer is not -3 and it is 1/4. If I were to multiply, alright, let's start with the 1/4. Alright, let's pretend we don't know about the direct numbers piece of thing just yet. 4 by 1/4. How many people here could work this out for me? I'm multiplying 4 by 1/4. Let's hear it. Tell me, what will I get? You could tell me what we need to do. Okay, just now listening to one person, so I heard 4/1. Continue for me. So we're going to put 4/1 multiplied by 1/4. There we go. Lovely. So that's one way of looking at it. Another way of looking at it is from here, where you can cancel off the 4 in the denominator and numerator, and you just get your answer to be 1 as well. So this is the reason why the answer is 1/4 and not -3. And here's why it is not -3 for the people who, probably thought about -3. I want to make sure and highlight the difference, so that way you do not confuse yourself with your arithmetic with directed numbers, and it will hopefully save you the opportunities that might go awry with directed numbers. So here we go. Somebody tell me, what is the operation here? What is the operation here? Multiplication. What do we do to work out this statement? We have to do multiplication. How do we multiply directed numbers? Do we just ignore the fact that it is a multiplication and just think about 4 and then take away a 3 and we get 1 as the answer? Or do we continue with the convention of multiplication, meaning we do what we typically do? So when we find the product of 2 numbers, don't we normally multiply the 2 numbers by each other? Yes. So remember, directed numbers, although directed numbers are a bit of a headache on their own at times, they're pretty simple once we remember rules. And one of the things we need to remember is that this operation of multiplication doesn't change. You still have to multiply 4 by negative 3. But to get this product, what will we do? Anybody? What will we get as the answer? Negative 12. Negative 12. I heard in negative 12. So many people said negative 12, and that is the answer. Alright? That is the answer. Why? Because you're going to do 4 by 3, which gives us this 12. And then we are multiplying a positive number by a negative number, and we get a negative answer. So we need to remember our rules for directed numbers, so that way we don't go making mistakes that could cost us the final answer, and then we get lower marks, and then we're like, Miss, my answer is correct. I did the right thing, but you confused yourself when you had to do your operation. Alright? So try to make sure that you will learn off your rules for directed numbers, so you do not, I repeat, do not ever make that mistake and take that 4 by minus 3 will give you positive 1. Alright? Don't ever make that mistake again. So what we're going to do now that we've looked at types of numbers, we went over BODMAS, we talked about laws of arithmetic, we talked about identity, we talked about inverse, we're going to talk about those directed numbers, and basically we will have term 1 summarized somewhat nicely in this video. Alright, so let's talk about directed numbers now, and you'll realize that directed numbers kind of sneak up on us in everything that we did just now. So we talk about the directed numbers. We said that directed numbers, we have positive numbers, negative numbers, and 0. Alright, anybody wants to tell me what is the sign on 0? Neutral. That's it. It is neither positive nor negative. Alright, and we said that when we do the number line, we always have to remember that negative numbers go to the left and positive numbers go to the right. Alright, so we have negatives, we have positives, and then we have 0, who's just neutral. No positive, no negative. Do not ever write negative 0 and positive 0. And I think I told you all last term. Was it you all or was it my phone twos? But anyway, my dad was out somewhere and he saw an air conditioning company advertising, right? And the name of the air conditioning company was negative 0 air conditioning or something like that. And he came back home and he told me, he was like, I see a air conditioning place that do exist. I was like, what? Not even making sense. So he was like, how they could call themselves negative 0? They do exist. It do have anything like a negative 0. So this is why I'm telling you, do not ever at any point in time in your life, not in your secondary school years or even beyond, write negative 0 anyway. You will let down all your maths teachers, okay? There is nothing such as negative 0. If you want any negative temperatures, start from negative 1. Alright? So this is our number line. Now we're going to talk about doing some arithmetic with directed numbers. And we already had started with dealing with things like the addition and multiplication earlier. Now, the rules for multiplication and division are so simple. So I'll start with those. When we do multiplication, anybody remembers the rules for multiplication of directed numbers? Let's hear them. Beautiful. Lovely. Nice. There we go. Lovely. And she did it in such a nice way as well that you can notice that when we multiply two of the same signs by each other, you will get a positive result. And if you multiply two different signs by each other, you will get a negative result. So I love that. Alright? What about division? Who would like to tell me what they remember about the rules for division? So when we divide directed numbers, what do we need to remember? Anybody? Lovely. Excellent. Continue. Lovely. So you all did such an excellent job. And again, you see the connection here. You divide two different signs, you get negatives, and when you divide two same signs, you will get positives. Alright? So this is something that we need to remember, the multiplication and the division rules. So this is the reason why earlier, just now when we were talking about that 4 by that minus 3, we wasn't going to get no negative 1 or positive 1, I should say. You would have gotten a negative number because we had a positive by a negative, so we knew we were going to get a negative. But aside from that, we wouldn't get anything other than the product of 4 by 3. Alright? Now, the addition rules and the subtraction rules. Anybody want to tell me what they remember about doing addition of directed numbers? So it's not as cut and dry as the multiplication and division, but I'm sure some people might remember something a little bit catchy but cringy at the same time to recall the rules of addition of directed numbers. So anybody want to tell me what they remember? Oh wow, time fly already, you all. It's like 10 to 12. Tell me, go ahead. Right? Okay, so, alright. So I'll explain what she was trying to say just now, because she has a very good example here. She illustrated it properly, right? -1 plus -2 is -3. And what I would encourage you all to go over is the rules for the addition and subtraction in particular, right? But as she said, same signs, what you actually have to remember here is when you're doing addition, same signs, you add the numbers. And if the two numbers have the same sign, then your result will also have the same sign. So same signs, you add the numbers, alright? So let me just take off that plus here, don't mix it up for being positive, right? Same signs, add. Anybody remember? Okay. Anybody remember the guy saying same signs add, different signs subtract? That guy. Exactly, that guy. So anyways, that guy taught you all how to do addition, and he also in the same breath taught you all subtraction, and he talked about product, quotient signs, same rules apply. So yeah, go look back for your Form 1 stuff. All the resources will be on Teams as usual. So just go look for your stuff in the class files and you will have access to everything to go review those directed numbers, alright? So you all, like I said, time certainly flew on me. I did not realize it. So I have to run off now because I do have my Form 2s in a little bit. And you all will have classes as well. So do enjoy the rest of your Tuesday. You all take good care of yourselves.